What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Network Plus 009 certifications. So let's get into it. In the evolving landscape of IT infrastructure, cloud computing has become a cornerstone for organizations striving for scalability, cost efficiency, and agility. And CompTIA's Network Plus certification, this underscores the importance of understanding cloud concepts and connectivity options as part of network management and design. And in this video, I'm going to provide you an in-depth overview of these cloud topics to help you ace the objective 1.3 of the exam. All right, so let's begin by talking about network functions virtualization. So network functions virtualization revolutionizes traditional network architectures by virtualizing hardware-based network appliances. Instead of relying on proprietary hardware, NFVs, they leverage software running on commodity servers to perform tasks such as firewalls, load balancing, and intrusion detection systems. And here are some of the key benefits of NFV. So there's cost reduction. So they minimize reliance on expensive proprietary hardware. You can easily deploy new virtualized network functions as demand increases, and it simplifies network updates and changes by enabling dynamic reconfiguration. Also, NFV is foundational for cloud native environments where they allow service providers to adapt quickly to changing requirements while reducing operational overhead. All right, next let's talk about a virtual private cloud. So this is a logically isolated section of a public cloud that provides users with a private environment to deploy and manage resources. And organizations, they can control their own subnets, route tables, and IP address ranges within a VPC. And some of the key features of a VPC include the following. So there's logical separation of resources from other users of the public cloud. You have control over network configuration, such as IP address ranges and subnets. And there's enhanced security measures, such as network security groups and access control lists. And also, VPCs, they are ideal for organizations that need the flexibility of public clouds while maintaining control over their network infrastructure. All right, next let's talk about network security groups and network security lists. So network security groups and network security lists, they are essential for controlling access to resources within a cloud environment. So a network security group, it acts as a virtual firewall at the instance level, and NSGs, they allow or deny inbound and outbound traffic based on rules that are defined by the user, and they typically operate at the virtual machine level. And then when it comes to a network security list, they operate similar to an NSG, but often at the subnet level, controlling traffic flow between subnets or external networks. Now, both tools, they are critical for enforcing least privilege and safeguarding cloud-based resources. All right, so moving on, let's talk about a cloud gateway. So gateways, they play a pivotal role in connecting cloud networks to external networks. And the key types include the following. So you have what is called an internet gateway, and this provides scalable and secure access to the internet for resources within a VPC. And then we have what is called network address translation gateway, or a NAT gateway. And this enables outbound internet connectivity for instances in private subnets while preventing inbound connections. And NAT gateways, they help maintain security by hiding private IP addresses from external networks. And also by strategically deploying these gateways, organizations, they can ensure seamless and secure cloud connectivity. All right, so moving on, let's talk about cloud connectivity options. So cloud connectivity options, they determine how organizations connect to their cloud resources. And the primary options are as follows. So we have what is called a VPN, or a virtual private network. And this securely connects on-premises networks to the cloud via encrypted tunnels over the internet. They are cost effective and straightforward to set up, and they are suitable for small to medium-sized businesses with limited budgets. And then we have what is called Direct Connect, and this provides a dedicated private connection between an on-premises network and the cloud. It offers lower latency and higher reliability compared to VPNs, and they are ideal for organizations requiring consistent, high-performance connectivity, such as in data-intensive applications. Now, both options serve different needs, and organizations, they often choose based on performance requirements and budget constraints. All right, so let's move on and talk about cloud deployment models. So, cloud deployment models describes how cloud services are implemented and utilized. And the three primary models are as follows. So, the first one is the public cloud. So, this is where resources are owned and operated by a third party provider and shared among multiple users. It offers cost efficiency, scalability, and reduced maintenance responsibilities. Some examples are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Then there's the public cloud, and this is dedicated to a single organization providing enhanced control and security. And it can be hosted on premises or by a third party provider. And it's ideal for industries with strict regulatory requirements, such as healthcare and finance. And then there's the hybrid cloud, and this combines public and private cloud environments, allowing data and applications to move between them. And it provides flexibility for workload distribution and cost optimization. And an example use case would be where you would run sensitive workloads on a private cloud while leveraging public cloud resources for less critical tasks. All right. So next, let's talk about cloud service models. So cloud service models, they define how services are delivered and consumed. And the first one is called software as a service. And this delivers software applications over the internet on a subscription basis. It provides infrastructure, application management, and updates. And examples of this could be Microsoft 365, Google Workspace, and Salesforce. Then there's infrastructure as a service. This offers virtualized computing resources such as servers, storage, and networking. And the users, they have control over the operating systems, applications, and middleware. And examples of this would be AWS EC2 and Microsoft Azure virtual machines. And then there's platform as a service, and this provides a platform for developers to build, test, and deploy applications without managing underlying infrastructure. And examples of this would be Google App Engine and AWS Elastic Beanstalk. Now, understanding these models is crucial for selecting the appropriate service type that are based on your organizational needs. And if you still don't understand the differences between software as a service, infrastructure as a service, and platform as a service, here is pizza as a service that can hopefully put this into context for you. All right, so let's move on and talk about scalability. So, scalability, this refers to the ability of a cloud environment to grow or shrink resources to meet changing demands. And this includes what is called vertical scaling. This is where you add more resources like CPU and RAM to an existing instance. You have horizontal scaling. This is where you add more instances to distribute the workload. And cloud providers, they use automation and orchestration to ensure seamless scalability, which enables organizations to handle functioning workloads efficiently. The next concept is called elasticity, and this is a specific aspect of scalability that involves automatic provisioning and deprovisioning of resources in response to real-time demand. And this ensures organizations only pay for what they use. So, for example, an e-commerce site that's experiencing a surge in traffic during a sale, they can automatically scale up their resources. And once the traffic subsides, the resources scale down to minimize costs. So elasticity, this is a hallmark of cloud computing where it provides cost efficiency and dynamic resource management. The next concept is called multi-tenancy, and this allows multiple customers or tenants to share the same physical infrastructure while maintaining logical isolation. So each tenant's data and applications are securely segregated. And the benefits of multi-tenancy include the following. So there's cost efficiency. So the shared resources, they reduce the overall cost for each tenant. There's resource utilization, so they can maximize the efficiency of cloud resources. And then there's maintenance, where they have streamlined updates and maintenance across all tenants. And cloud providers, they employ multi-tenancy to deliver scalable and cost-effective solutions while ensuring security. All right, so to wrap this lesson up, mastering cloud concepts and connectivity options, this is critical for IT professionals aiming to achieve the CompTIA Network Plus certification. From understanding NFVs and VPCs to grasping the nuances of deployment and service models, each topic forms a fundamental building block of modern network design and management. Now, as organizations increasingly adopt cloud solutions, proficiency in these areas will not only help you pass the Network Plus exam, but also enhance your career prospects in the dynamic world of IT networking. And by leveraging this video, you're well on your way to understanding and implementing effective cloud strategies in real world scenarios. All right, so with all of that being said, let's do some of this wonderful check on learning. So, the first question is, what is the primary purpose of a network address translation gateway in a cloud environment? Is it to provide encryption for secure communication between cloud resources? Is it to enable private instances to access the internet without exposing them directly? Is it to restrict incoming traffic based on predefined rules? Or is it to connect on premises networks directly to cloud resources? And the correct answer is it is to enable private instances to access the internet without exposing them directly. So, a NAT gateway, this enables private instances in a virtual private cloud to access the internet while keeping them hidden from incoming external traffic. This enhances security while providing necessary external connectivity. Next question. Which of the following best describes elasticity in cloud computing? Is it the ability to scale resources up or down automatically based on demand? Is it hosting multiple customer environments on shared hardware? Is it assigning static resources to meet projected workloads? Or is it connecting on premises networks to cloud environments? And the correct answer is it is the ability to scale resources up or down automatically based on demand. So, elasticity, this refers to the capability of a cloud system to automatically adjust resources up or down to meet changes in workload demand, ensuring efficiency and cost savings. And our final question, what is the key difference between infrastructure as a service and platform as a service? Is it infrastructure as a service provides managed software solutions while platform offers unmanaged hardware? Is it infrastructure provides virtualized hardware resources while platform includes tools and frameworks for application development? Is it infrastructure includes email and collaboration software while platform offers storage solutions? Or is it infrastructure scales automatically while platform requires manual scaling? And the correct answer is infrastructure as a service provides virtualized hardware resources, while platform as a service includes tools and frameworks for application development. So, infrastructure as a service, it offers virtualized computing resources such as servers, storage, and networking. In contrast, platform as a service provides a platform with tools and frameworks for application development and deployment, abstracting much of the underlying infrastructure.